Hello, good morning. I, SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Today, video 134. It is about alkadienes or diolefins. It is for BSc Part 1, Organic Chemistry, Paper 2, Unit 2. Dienes are classified into three classes. Cumulated dienes. If two double bonds, carbon-carbon double bonds, are adjacent to each other, for example, 1,2-propadiene or alene, it is a cumulated diene. Conjugated dienes, two double bonds are separated by one carbon-carbon single bond, then it is known as conjugated dienes. For example, 1,3-butadiene. Isolated dienes. If two carbon-carbon double bonds are separated by more than one carbon-carbon single bond, for example, 1,4-pentadienes. Relative stabilities of dienes. Cumulated diene, if it is treated with 2 moles of hydrogen, it will liberate 70.5 kilocalorie per mole. And if isolated diene, 1,4-pentadiene, if it is hydrogenated, it will liberate minus 60.2 kilocalorie per mole. If 1,3-pentadiene conjugate diene, if it is hydrogenated in presence of platinum, it will liberate 57.1 kilocalorie per mole. And we know that stability is inversely proportional to delta H value. Here, delta H value of this molecule is less in conjugated dienes, that is 1,3-pentadiene. So it is more stable compared to isolated dienes and compared to this cumulated dienes. So on the basis of heat of hydrogenation, we can calculate the stability of the alkadienes. Conjugated dienes are more stable here than isolated dienes, and then cumulated dienes are less stable. Methods of formation. Preparation of cumulated dienes, allenes. From 1,3, it can be prepared from 1,2,3-tribromopropane. If 1,2,3-tribromopropane is treated with alcoholic KOH, then it will dehydrohalogenate it, and then in presence of zinc and methanol, it will dehalogenate it and gives alene. From terminal alkynes, we can prepare alene from terminal alkynes. If propyne is treated with alcoholic KOH, it will rearrange to alene. From haloalkanes also we can prepare allenes. See here, in presence of alkali. From alkenes. From alkenes also we can prepare alene. From dihalocyclopropane we can prepare alene. See here how this dibromocarbene is injected to ethene and it will give us the alene. Preparation of conjugated dienes. Conjugated dienes also can be prepared by from normal butane on dehydrogenation of butane, normal butane. It is thermal dehydrogenation. When normal butane is treated, this chromium oxide at a higher temperature, it will dehydrogenate it and it will give mixture of 1 butane and 2 butane. Then on further dehydrogenation, it will at higher temperature, it will give us 1,3-butadiene. Pyrolysis of cycloalkenes, it is called retro-Diels-Alder reaction. If cyclohexane is treated with nichrome catalyst, it is a mixture of nickel, chromium, iron. Then we will get 1,3-butadiene and ethene. Dehydration of diols. When 1,3-diols or 1,4-diols are dehydrated in presence of acid, strong acid, then we will get this 1,3-butadiene. Dehydrohalogenations of halohydrocarbons also produce this 2-methyl-1,3-butadiene or isoprene. It is also known as isoprene. From acetone, this acetylene, when reacted with acetone, it will give this intermediate, which is on partial reduction. It will give us isoprene. Preparation of isolated dienes. Dehydrohalogenations of dihaloalkanes. See here, it is a 1,5-dibromopentane. In presence of alcoholic KOH, it will give us 1,4-pentadiene. Wood's reaction. When allyl chloride is treated with metallic magnesium in ether, isolated dienes or 1,5-hexadiene is obtained. See here, this chloro compound we can take means halogen. See here, it is called allyl chloride, or we can take allyl bromide. We can extend the length of this carbon here, and when treated with magnesium, so it will give us magnesium chloride. In presence of ether, it will produce 1,5-hexadiene. Structure of dienes. The structure of isolated dienes is similar to that of alkanes, but the structure of cumulative dienes and conjugated dienes are somewhat modified by the interaction of two carbon-carbon double bonds. Structure of allenes, cumulative dienes. See here, cumulative diene is here, carbon is sp hybridized, this is sp2 hybridized. Bond angle is 118.4 degree. C1 and C3 are sp2 hybridized, C2 is sp hybridized. Molecular orbital structure. Molecule having considerable strain and hence reduces its stability. Here, this double bond having 1.31 angstrom, shorter than the carbon-carbon double bond, 1.33 angstrom. Structure of conjugated dienes. 1,3-butadiene having stability due to all carbon atoms are sp2 hybridides. Here, 1,3-butadiene. See here, its bond length. Double bond length is slightly higher and single bond is slightly lower. So we can see due to the delocalization of pi electrons, their bond lengths are affected. Conformation of 1,3-butadiene. See here. We can get two types of conformation. This S-cis conformation, it is less stable. Trans conformation is stable. Stability of conjugated dienes. Heat of hydrogenation. 1-butene is on hydrogenation evolved minus 30.3 kilocalorie per mole. 1-butene will liberate this minus 30.3 kilocalorie per mole. So this expected is 60.6 kilocalorie per mole. But experimentally, value of delta H for 1,3-butadiene is found is minus 70.1 kilocalorie per mole. So difference is minus 3.5 kilocalorie per mole. So thus the 1,3-butadiene is stable by minus 3.5 kilocalorie